الدكتور يديش كشف
لا الله يبارك يعطيكم الصحة. نبدو؟ شكرا. نبدو
Salam alaikum. On nous rend assistance. Nous avons aujourd'hui d'entamer la deuxième partie de la conférence, à partir de soirée. Donc, les filles, trois présentations. On va regrouper deux sessions dans une seule. On va commencer par la première présentation du monsieur Masoud Baba Rayo, qui est intitulé an AI Assisted Framework for Task Overfloating in Edge Computing. Ayant comme co-auteur M. Nourdine Chaïs. Oui, vous pouvez faire. Donc on va commencer la première présentation. Et bismillah.
Bismillah ar-Rahman. Assalamu alaikum. I would like First, I would like to thank you everyone for coming here and for having me in Jury, the 4th edition. So, as I was already presented, I'm going to present the work that's entitled An AI-Assisted Framework for Task Offloading in Edge Computing. We are going to see some interesting concepts. I'm a second-year PhD student. Well, without further delay, let's get started. First of all, we are going to see what a cloud computing is. Then we will see edge computing, this fancy paradigm. Then the energy challenges and AI for task offloading decision. We are going to describe what's AI and how we can apply AI for the offloading decision problem. After that, or lastly, we will give some final thoughts. So part one, cloud computing. You already know about this concept. Cloud computing in general is about to provide some services to the end devices like your laptop, your smartphone, so you will get a service across the internet. Let's give some concrete examples. For example, for storage, when you need to store some data, you will use services like Google Drive or OneDrive. Number two, computing power. Sometimes your computer is not able to process all huge tasks, so you need to send them to the cloud for this aim. The other one is software applications. For example, you have LaTeX, you know the editor LaTeX. You can use something called overlay. Overlay is to process or to compile your LaTeX code in the cloud. The fourth one is development tools like GitHub. So you can, or Colab, Google Colab. These are environments for you, are given for you to do your tasks. However, until now, cloud is working perfectly. However, there is a problem. It's precisely its statistics. There is a growth of like 13 billion mobile devices by 2030. This is according to Global Eve Outlook. It's since 2 years. This results also in a growth of 4% of global electricity demand by mobile devices by 2030. This is a big number. So someone can tell me how can this augmentation impact our cloud functioning? Well, number one is bandwidth saturation. If you have billions of devices that are accessing the cloud at the same time, this will introduce bandwidth saturation. We are talking about IoT devices, mobile devices. Number two, bottlenecks. Imagine that all these devices are going to the cloud, accessing a single point like a router. This router cannot support this huge, this charge. Number three, high latency. Because the cloud is too far away, so you need to wait for some amount of time for you to get the results back. In some applications, this one is not tolerated. Number four, internet isolation problems. You are working on your LaTeX file that's hosted on the cloud using overlay, and suddenly you got disconnected from the internet. This will stop your work. This is an inconvenience, etc. There are some other issues. Now comes edge computing. You can guess that edge comes to solve this issue. So what's edge computing? Let's describe it again, as we did with cloud. Edge computing is about to provide some services for the end devices like laptop, drones, vehicles, the different applications. So, but instead of using the cloud alone, we added another layer which is in between. It's called the edge servers layer. This one gives you some edge servers that are strong, not as data centers, but they are strong and they can tolerate the tasks that you send them from your end devices. Let's see what benefits exactly can edge provide us. The first thing is low latency. Unlike cloud, edge servers are too close to the end users. So instead of going to the cloud, I will go to the edge server that's connected on the LAN. It's in the same local area network. So this will result in a very low latency, which is in our favor. Number two, bandwidth saving. You do not go to the internet unless it's a necessity. If you can do the task by just going to the edge, then you can do that. This will let the other applications that need to go to the internet, it will free the bandwidth for them. Number three, energy optimizations. So the cloud, by definition, are using a lot of resources. But if you bring edge servers, in edge servers they have some CPUs that are built just for this purpose, for the energy purpose. They are specialized as processors and resources. Number four, offline working. If you got disconnected from the internet, you can still operate. Why? Because the edge server is in your local area network. Even if you got disconnected from your internet service provider, you still can work. So let's give some concrete edge applications. In brief, the services or the applications that benefit from edge, we can see that there is the industrial systems. You have a production line, you have a robots. It needs to make a fast decision in a very low latency. So it will not ask the cloud about the decision, whether to pick the item, drop it. It will just ask the edge server for that. Number two, self-driving cars and drones. We already saw this this morning. So you have a decision to take, whether to turn left or turn right, like killing the old guy or the baby. So in this scenario, we do not ask the cloud for the decision. You need to make the decision instantly. You just ask the closest server that's available. Sometimes the cars itself can be considered as an edge server. So it will ask itself, and it will make a decision, turning right or left. Number three, healthcare monitoring. We need to monitor our patients in real time. Sometimes making surgery that's going to be like instantly. You do not want to make a delay during this operation or get disconnected while its surgery is already going. We have security systems like surveillance cameras. We need to know whether there is a thief or not in real time. There is mobile augmented reality. It's the XR family. We have augmented reality, virtual reality, mixed reality in general. There is network gaming. It does not tolerate latency. Gamers call this lag. They do not accept lag. The other one is smart agriculture. These robots also need to make instant decision, even if they are disconnected from the internet. They need to still keep working. And there is smart grids, everything that's related with energy. Now let's move to the part three. We saw what are clouds, their inconvenience. We saw that there is edge, its benefits, some of the applications of edge. Now let's see where energy challenge come exactly. So let's see this. We have mobile and IoT devices have some special constraints. This is already known. They have limited battery lifespan as sensors and your mobile devices, and they have limited computing resources. They are not like servers. They have so low limited resources. Also, the third one is some applications require low latency execution time. By definition, they do not tolerate a big latency time. From here comes the necessity for task offloading. Task offloading is when you have a smartphone like this one that has limited energy, you do not want to make your processing inside this device, so you need to send it to the edge server. This operation is called simply task offloading. So I need to send the task, I need to upload it to the server. The server makes the results for me and send it back in a very short amount of time. So the idea, I will repeat it, is to offload the task and get the results back in less than the application's threshold time. I need to make it in less than the application threshold time. This saves energy and execution times. This is obvious. However, if offloading costs much energy and execution time, then better to make local processing. Sometimes the cost of sending it wirelessly, this task, will consume more than making it locally. So it's about whether to offload the task to the server or make a local processing. A decision problem. Does it ring a bell when you hear a decision problem? You can guess that's about AI. It's about machine learning. We are trying to make prediction or decision. From here, we'll see how we can apply AI for our problem, which is our task offloading decision. So, the need to take a decision, offload or not, we are repeating, but it's okay. We need to define at first a set of parameters, because machine learning works using a set of parameters. Let's see exactly what are. They are called, by the way, they are called with the name features. Let's give a basic example, despite our exact thematic. Let's have this idea. We have red stars and green circles. And we have a new data. These two classes are categorized by two features, X and Y. So we bring our new data, which is defined as well by X and Y, and we will try to see whether it's close to the green circles or red stars. This is, in general, how we apply classification for basic problems. But in our scenario, we are going to use another set of features. The first one is the type of the applications. Imagine you are having remote surgery. It's not like having streaming, watching a movie, or they are totally different applications. Number two, the size of the task. I need to send the task to the server. There are a lot of sizes, so this also does matter. And there is the availability of the edge server resources. Sometimes the edge servers, they are not waiting for you to send them the task. Sometimes they are busy. You need to make this into consideration. Number four, state of the wireless channel. If it's charged, here sending the task may not be a wise decision. And there is the remaining device energy. We also should take this into consideration. We collect all these five in addition to the geolocation of wireless device. Let's imagine that I have my smartphone here and I try to offload the task from this environment, which is closed. There is a lot of interferences and obstacles. So offloading from this position or from the outside are totally different things. So if I'm here, I may prefer to make the local processing, because I know that when sending the task, I will experience a lot of retransmissions. So let's have a general idea. So this is the set of parameters, and they will be labeled with plus or minus. What does plus mean? Plus means that when sending the task under these features, I will get the results back correctly, successfully. A minus means that sending the task will not succeed. So I will have a lot of tests and experiments and see whether it succeeded or not, with a different set of features. Then after that, I will collect this data, I will consider it as a test set, then I will bring another sample, another task, like when we bring new data that we do not know whether to classify it in red circles, red stars or green circles. So now I will bring a new task and try to predict whether it's going to succeed or not. This is the idea. So our proposed technique, let's put it in simple words, is the use of the set of features, the 6 features, to determine whether to offload or make a local processing, based on the large set of training sets. We said that we iterate a lot of times, which is called also experience. Bringing a new case, a new task, and try to see whether it looks like a successful or unsuccessful offloading before making the decision.